right before lunch, we were graphing the step function or greatest integer function, where if you put in any number at all, you basically truncate that number and you just write the integer. So the domain for that would be you can put in any number at all. The domain is all real numbers. However, the range, when I get out the numbers, the y column in our table, what is my range? We need to summarize that. I can't hear any of you saying. You're like whispering to me here. What? What do you think? Integers. Yeah, they're the integers. Some of you did interval notation last year. You cannot write the answer integers in interval notation because somehow you'd have to show every single integer. Big pain. So we'll just write all the integers, or there is a symbol if you like symbols. Right? All integers. Or you can write the symbol. It looks like this. Integers. The graph is what between each pair of consecutive integers. From side to side, between each pair of consecutive integers, what kind of graph? I said the word a few times. I'm not sure if you were listening. Yes, somebody said it. Somebody said it. Terry, yeah. It's constant. Straight across, constant. And then it jumps vertically at each of the integer values. So here we're going to sketch some greatest integer functions. If you know how to use transformations, you could take this graph and just transform it. For example, what would the +1 tell me? Transformations. We go up 1. So if we just take this graph and we move it up 1, we can graph it. If you do not know transformations that way, then you can just plug numbers in and graph what you get out. I'm going to use transformations, and I'm also going to change my scale so I don't have to draw as many steps. I expect that you do draw the amount of steps that will fill up the whole graph, but if you zoom in a little bit, that's okay. So instead of starting at 0, 0 like I did on my parent function, I'm going to start at 0, 1, and then jump up at 1 to 2, and follow that pattern. And then for h of x, we can use a table. We could use transformations if you remember them. I'm going to kind of copy my table from up above. 0 to 0.9 is 0, 1 to 1.9 is 1, 2 to 2.9, 2, 0.9 is 3. So if I use just the greatest integer function for x, after that, then I would multiply all those answers by 2. So once I got the f of x answer, the 0, the 1, the 2, the 3, once I got those integers, then I'm going to take all those integers and multiply them by 2. So I'm going to get 0, 2, 4, 6. And this graph would go, I'm going to re-copy it. So this one will have the exact same 0 to 1, but then it's going to jump up to 2 and jump up to 4. So as I follow my pattern, there's like 2 blocks in between each instead of 1. So that one had a vertical stretch on it. And I'm going to pass out the worksheet. The worksheet is just more practice graphing. And you can do transformations, or you can do tables, however you're most comfortable graphing. The one thing that I would really suggest you don't do is just graph it on a calculator and copy those answers.